I just find it unimaginable that we can't poke the curve with a stick. Can't poke Earth's curve with a stick, not the squared part, not the squared function, not the squared drop exponentially from itself. Like it's just weird, right?
Well, heck, they can't even make a straight line. So yeah.
Oh, I'm glad that's just speculation because I believe there's lots of straight lines, and those straight lines don't increase in elevation or decrease, not to the left and not to the right. And you can't take a portion of it and stab it into water, and it can't pop out of the curved water either. So therefore, no curved water. You don't have
How,
physically curved.
how straight are those lines?
Can we make a straight line?
Yeah.
How straight are they?
How curved are they is the question.
No, you said there's a lot of straight lines. How straight are they?
Oh, they're straight.
How
They're
straight?
still. They're still.
How straight?
Oh, they're straight. Look at the Egyptian pyramids that they boast about every day of their life with
How come
straight
you can't
lines.
answer how come you can't answer the question? How straight are they?
Well, what's the word straight mean? That's what they are. From point A to B the fastest way. What is that to you?
How
Is
come you
that
can't
not
how come
straight?
you can't how come you can't answer the question?
I just did.
How
Straight is
straight?
the word straight.
How straight are the lines?
They're straight, brother.
You think you can draw a perfectly straight line?
Yeah, you can draw straight lines. You think you can
Right.
draw an earth curve?
Listen to my question. See if you can answer it. Do you think you can draw a perfectly straight line?
Yes, you can't draw an earth curve
Okay, how would you draw a perfectly straight line?
with your hand or a machine or a printer or use the paper you got and say, look at that paper that the in the classroom. That's pretty straight on those papers. Those aren't
Pretty
straight
straight?
lines.
Okay. So pretty straight. I love when you back away from your answer. Pretty straight,
Well,
not
no, I told you
perfectly
the word straight, but you just don't like that. The word
straight. I
straight is
like
only one word. Does the word straight mean something different to you than it does to me? I'm lost.
yeah, I know you are, but you can't draw perfectly straight lines.
You don't know what the word straight means, apparently, or earth curve. You draw the two. Show me you know what that even means. Because I do. I just can't draw an earth curve. We can all draw straight lines. That's what a ruler is. And a
No, you
meter
can't.
stick and an inch and a mile
No, you
on that
can't.
map, the key legend, it's a
No,
straight
you
line
can't.
down there, buddy.
No, you can't.
Then how did they do it on a map?
How
What's
straight
that
is that
line on a
line?
map to tell you distances?
How straight is that line?
It's not curved.
You can't answer the question. It's so
I
cute.
just did. It's straight line that's not curved. You have a
How
mental
straight?
block. You
How
don't like my
straight?
answer, not my problem. Your problem.
How straight is the line?
I don't know how crooked is a straight
I
line
know you
to
don't
you.
know. That's why I'm asking you the question because I know
Brother,
you
I
don't
got
know.
one reality. I don't got 10 realities. You
That's
must
fine.
have 20 different straight lines in your mind or something crazy going on. It's a straight line. Now, whatever that
Deflection.
means to you, you just keep making stuff up.
Yeah, that's the thing. You don't know what a straight line is, or you don't know what the tolerances of a straight line are, and that's fine. I don't expect you to, but when you say stuff like that, it just doesn't
I
make
told
those
you what it, I told you it's the shortest point between 2 points. The shortest distance between 2 points is a straight line. That's how you make the straight line. The shortest one, no deviations
you can't
between
draw a
2 points.
you can't draw a perfectly straight line.
No, you can't, apparently.
No, you can't.
You've never seen what I've drawn. Stop making stuff
It
up.
doesn't matter. I know it's not straight.
So you know things without seeing them ever happen or anything?
Yep.
It's weird.
Yep. Yep. There will always be deviations in whatever you can draw.
Yeah, but is there an earth curve? Where's the earth curve in that
Why
deviation?
why are you
What do you mean?
deflecting
Wait, wait,
now?
wait. Stop jumping the conversation here. I
No,
can make a
you're
straight
deflecting.
line. You
Why
can't
are you
make an earth
deflecting?
curve. Don't
It's so
run.
fun. It's so no, it's you. You're running from
No,
a
it's you
straight
don't
line
know
to
what a
earth
curve
curve.
is. Now you're afraid of a curve. We've covered the straight
I'm
line. I
not
can
afraid of
make
a
one.
curve.
You can't. You don't like it that I can. I got you. You hate it. Your
No.
feelings are involved. Now, where's an earth curve without feelings? Can you draw that and not a straight line?
Why are you getting angry, Democh?
I'm just wondering how you draw an earth curve, guys.
You can't
Why
draw
are you
straight
getting angry
lines.
about earth curve?
I'm not angry about Earth curve.
Well, then draw it for us.
Draw it
Yeah, draw it out. Draw the earth
What-
curve out on the wall. What is
to
an earth curve?
scale.
The
To
squared
scale.
part.
To scale.
Yeah, the earth
You want
curve, the
me to?
squared
You want me
part,
to
the 8
draw?
inch, 32 inch.
You want me
Yeah,
to
the
draw?
squared part. How does that
You want?
work against the vertical, horizontal?
You want me to draw a curve the size of the Earth? Is that what you're asking for?
I want you to draw the portion of the earth curve that squares its function. Like you're at the end of 3 miles, you put your pencil there on the wall. That's the end of 3 miles, and you keep going with it. Show us that squared drop part. How far the drop is, what that looks like. Can you do
Sure.
this, or you have no clue
Yeah.
what that is? You don't
Yeah.
have a clue, do you?
No, I do.
Draw it
A,
out.
s- a sphere doesn't have a drop. It's constantly curving. Show me the drop on your soccer ball.
That didn't make any sense. That didn't make any sense. It
I know
wouldn't
it
be a
does to
ball
you.
if it didn't
You're,
have drop from a
you're
I know
horizontal.
asking
it
him to
does.
show you a drop on a sphere. There
It's
is no
not
drop.
matching with a horizontal. The soccer ball does not line up with a
There is no
horizontal.
horizontal on a sphere.
Correct. Now we're going to draw a straight line. Now you draw the sphere. What does that mean? What
There
is
is
the
no
sphere to you?
horizontal in real life either.
There is a
Can you
horizontal on
can
a
you just
sphere.
draw the earth for me? Stop making stuff up. If you don't know what the earth curve is and you don't believe in it, please don't chime in.
Okay.
I
Okay.
want
Hold
the
on.
There,
people who
there,
believe
Hold
they
on.
have
there,
earth curve math and earth curve 3D printed out on LIGO, GPS, whatever, draw it out.
Okay. I will
there is a,
draw it as soon
hold
as
on.
I will draw it out as soon as you draw the flat Earth.
All right. I don't know what you guys mean by draw, but you'd have to define. I don't know what you're talking about on a wall or something. I don't know. But there is a
Yeah.
horizontal on a globe. It's a tangent from the center of the Earth, and it's a imaginary line that goes off from one point 90 degrees from the center, from the line, the plumb line that goes down to the center of the Earth. And then if it was curving, that curve would drop from that horizontal.
We're not talking about imaginary. We're talking about actuality. There is no drop. It's
There is
curving
a drop
always.
from the horizontal. You could put like a ruler on a soccer ball, and then there's a drop from that ruler down to the curvature of the ball, of the soccer ball.
Yeah, well, the great thing is there is no horizontal. It's curving. Anyways, back to Democh. Democh, sorry for the interruption.
No, he said the same exact thing as me. There's no straight lines on that ball. They would deviate. There's no corners on a sphere.
You
There's no
can't
corners.
draw. You can't draw a line as straight as Earth curve.
There's no such thing as earth curve. How could I? I can't draw imaginary, non-existent things. You're right. I can draw a straight line
No,
though.
you can't. You can't draw a line as straight as 8 inches per mile squared.
That didn't make any sense. 8 inches per
Sure.
mile squared vertically. Show me what that means.
Horizontally too.
No, it wouldn't be horizontal. Horizontal doesn't change.
You cannot
Doesn't
draw.
deviate.
You cannot draw a line that has a slope of 1 mile and then 8 inches up. You cannot physically draw a line straighter than that.
Then you have a problem, and there's no earth
No,
curve.
no, I don't. I don't.
Yeah, you do. Then it's not a physical earth curve anybody can touch and draw. It doesn't exist if you can't make it existable. You have to make it a real
You
thing
want
that we
to.
can all compare to.
You
What are we
want us.
comparing our earth curve to if you don't have one?
You want us to draw the shape of the Earth is what you to scale. That's what you're asking for right now. That's how dumb that sounds.
No, that's not what I said for the fifth time.
Yeah, it
I
is.
said,
It's exactly
imagine
what
you're
you're
at the
asking
third
for.
mile. I want the squared function, the squared part of the drop. A squared function of a drop of a sphere cannot match a horizontal line. That didn't make any sense. What are you talking
Yes, it
about?
can. On a piece of paper, you wouldn't be able to tell.
What are you talking about, dude?
Are you having trouble understanding my words?
Yeah, I'm having trouble seeing your curve on the wall. Made with dirt, ice, sand, mud, anything. You can't make it. Doesn't exist. You don't know what an 8 inch drop, a 16 inch drop compared to a 32 inch drop, compared to a 7 mile drop even would be. You have none of the above.
All right. Is
Show
there
us
some way
one
to make
drop.
this conversation cohesive? This is I don't know what you guys are even talking about. Drawing a straight line is actually a very difficult thing to do. We've talked about it at length in terms of what it would take to actually draw a straight line to compare,
Yep.
curved water or something to it. So is that what the conversation is? The difficulty or challenge of how to draw lines? Or it sounds like Democh's just assuming all lines can be drawn really easily and then somebody doesn't
Yep.
have an earth curve. Is there any sense to this conversation? Can we somehow make it cohesive or something?
Yeah, to make something physical, a real thing, you need to draw it or produce it for real.
Nope.
So if there's a real earth curve, somebody needs to make it for real.
Nope. If there's
Okay,
a
so
real
it sounds
flat,
like Democh's point is that if the water were curving or the earth was curving, he's trying to say you should be able to make a line that would follow that curve. Is that what he's saying? That drops at 8 inches per mile squared?
Yeah, it drops 8,000 miles, Gio, on each side, top, bottom, left, and right, and front and back. It's a
so
ball, man.
you're asking me to draw a curve the size of the Earth. That's what you're
No,
asking.
that's not what I said. I said, imagine you're at the 3rd mile part. You're a little bitty human. The earth's big, we know, but your hands are small and so are you. So you trace the earth curve, little guy, the one you claim exists in front of you that you have to go down below the water on your boat or your pontoon. Someone's existing. They're saying something physically exists there. And where's the math for it? I thought there was math and 3D printed, like, what are we talking about here? It doesn't
What?
exist.
Finish that sentence. Math and 3D printed what?
Mud and dirt that can be made into an earth curve in front of you, an 8-inch drop. What's that? Then what's 16-inch? Then 32. They can't look like each other and they cannot be a horizontal line.
Right. But
So what are they?
that line is so you can't perceive it from where we are.
That didn't make any sense. So you, as
No,
a
I'll
little
say
bitty
it slower.
microscopic human, the smallest
I'll say it
you're,
slower for you, Democh. We can't perceive that. Do you understand that?
then how'd you measure it and how'd you account for it with surveyors? How are you accounting for
Not
something
by
that's
drawing, not by
unperceivable?
drawing lines. Not by drawing lines. I'll tell you that.
So what does the cement represent in the line that the horizontal plumb line? What does that represent?
The
That's not a
cement.
line.
What cement are you talking about?
The one they put the buildings on to line all the corners up next to each other, the 72 cubes, and they're all touching, lined up. They don't diverge.
What
That
are you
doesn't happen
talking
on a ball.
about?
You don't put cubes on a ball and they
What are
line
you
up.
talking about?
A cube on a
Yes.
Ball. Now
Where are
you
these
don't know what a
cubes at?
ball is?
Where are these cubes at, Democh?
Shopping malls everywhere.
Do you know? You think buildings are perfectly flat?
Yeah, they're cubes. They're all
Wrong.
squares and
You're
rectangles,
wrong.
and the
See,
sides
that's
of
your
them line
problem.
up. Show me where I'm wrong on a ball. Show me
Geo
where I'm
just
wrong on a ball. Show
yeah,
me your representation of what a ball is with cubes.
Geo just explained it to you. There
No, you
are
don't explain, you demonstrate. Because you don't know what you're
okay.
talking about. Geo didn't
Demonstrate
put
flat.
cubes on a ball.
Demonstrate
Geo did
flat Earth
not
for
get a
me.
ball and put cubes on it and show me how they line up.
Okay,
All right,
demonstrate
just
flat
hold
Earth.
on, Democh. Hold on. What were you saying about what I said, Wesley? This is a very incohesive conversation. What did you say,
Yeah.
Wesley?
You were right. The foundations of buildings are not perfectly flat. So it goes to your point that you cannot draw a perfectly straight line or a perfectly the curve of the earth. You wouldn't be able to perceive it over a couple hundred yards. None of a contractor contractor can't even measure that
May
difference.
I interject a bit of a question to both of your stances here?
Yeah.
I'd like to know whether a globe or flat Earth, uh, who is saying that the horizon or the land or anything is perfectly flat anyway? It sort of seems to me kind of like a straw man argument. I'm not saying that it's not a bad argument, okay, or that it is a bad argument, but I don't know of anybody really saying that it is like a disc like flat plane or a disc or like a golf, well, maybe not golf ball, but like a cue ball like globe. In other words, it has mountains and valleys and stuff like that. I don't know if this maybe I'm just missing the point. And
My point
maybe
wasn't
that
topography.
point could be sort of clarified. Sorry.
Yeah, my point wasn't topography of Earth. It's a horizontal line with a vertical and a plumb. They represent each other. And then if you have an Earth curve, no matter how straight you want to say that microscopic line is up and down or not, who cares? The Earth curve doesn't exist against it. Nowhere to reference. So no one has a reference to be able to blueprint it or make it or build it or do anything with it because it's unimaginably unthinkable and it's undoable. It's unphysically presentable or physically tangible. There is no Earth curve, is what the gentleman just said. And now these guys built a foundation on Earth curve that's untangible and doesn't exist to anyone and couldn't in his own explanation. Not even the part that's 8,000 miles vertical from the one to the next. And this is ridiculous to say that nobody's flying vertically down along an 8,000 mile sea level on a ball. That's
So
ridiculous.
getting back to your original point, what is the predicted Earth curve drop over 100 yards? Which is
None.
a
Apparently, you haven't drawn it. What are we
Nope.
going with?
Try it
What's your
again. Try it
reference?
again. I'm
Do we
asking you
have a
what is
reference for physical reality that you are talking about something that we can use to line up? Stop saying try again. Where's the Earth curve I'm looking at to reference it? If you
All right.
have that, we'll take a peek.
what's
All right. Can I get in, Wesley? Over 400 yards, it's 12
no
millimeters, and this
no
is an
oh
argument
sorry.
that Rob makes. Hold on. This is an argument that Rob on the level Keen makes, where he talks about. Oh, his name is Rob Keen. If you've seen him in here, but I don't think he's in here right now. That over 400 meters, actually not yards, 400 meters, it is 12 millimeters of drop, and he talks about using an auto level with a water level, and that 12 millimeters is not measured. So I was saying before that it is more difficult than one might think to make a straight line over long distance. We've talked about all kinds of ways of doing it. Doesn't mean it's impossible, but it's a project for sure. But that doesn't mean you can't make like a horizontal plane of reference. We could get into like plane surveying and so on in terms of being able to make a horizontal plane and the accuracy, and there are some people that have done this and then compared it to water to see if the water is curving. So it's not necessarily that it's impossible to do, but it is elusive that in 2025, there are no like tangible actual measurements of water curving or of the earth curve. And we get into the claims of the earth curving. There's, geodetic surveying, which uses GPS and all kinds of calculations and, isn't actually physically measuring the curve. So, and there is something to be
So
said for the fact that it really has never been measured, even all the way to this day, with the claim that the Earth is this globe that's been discovered, 2,000 plus years
so
ago.
it has been measured. So, getting back to my point, over 100 yards, which is bigger than 90% of all buildings, 100-yard building, the drop would be 0.008 inches, and
Where's the
no
line? What
and
line are
no.
we lining it
Let
up
me
to? You got a
finish.
side
Let me
view?
finish. Let me
Okay,
Democh, you
finish
sorry.
want to
before you
finish?
get triggered. Over 100 yards, it's 0.008 inches. No contractor, no surveyor has a normal surveyor has the ability to measure 0.008 inches over 100 yards. There is no measuring device that's common to contractors that can detect that's within that margin of error. But to your point, the way that one way you can measure it is with reciprocal zenith angles, showing that it is curving. But other than that, you're not going to be able to tell over 100 yards. And no building has a slope or deviation less than or even close to 0.008 inches per 100 yards. That would be crazy.
Is that why the World Trade Centers fell?
Nope.
Because at 0.008 inches, at that size of a building, that height, they would have toppled over about halfway up.
No.
Yeah. Well, how big would that foundation have been? The size of New York?
What? This is a total
Seriously,
non
man.
sequitur.
Think about that. 0.008 inches at ground level, considering the World Trade Centers, okay? The towers that allegedly fell upon themselves. Think about that, man. Look how far off they would have been halfway up it.
Over 100 yards.
Yeah.
0.
You think
Listen.
it would have stood up?
Yes. 0.0008.
Yeah.
Yeah,
Okay.
so at 400 meters, the one that Rob usually uses, at 400 meters, it's 12 millimeters. And there's claims that these auto levels and these equipment can measure within 1 millimeter plus or minus. So if you're going 400 millimeters and you're within 1 millimeter plus or minus, if you measured 10 or 11, it'd be pretty close to 12. You could say, okay, that could be, you could be a little bit off. But if you're measuring 0, that's way
Well,
off
how
from
many?
12.
No, I understand. I get you, but how many buildings do you know that are 400 meters wide or long that are skyscrapers?
I don't know.
That's
I never
4
really
foot.
mentioned buildings. Was that to the cubed idea or something? I mean, the thing is,
Well,
like plane surveying is what's used in like virtually all applications that are on local levels. Like they use it within up to 100 square miles. So depending on whether that's 10 by 10 miles or rectangle or square, but 100 square miles, plane surveying is used, which doesn't involve any curvature. But if the Earth was curving, plane surveying would be able to measure that curve. Like actually, plane surveying wouldn't really even be a thing if the Earth was curving because you would never actually be using plane surveying. You would always be doing spherical. But with 100 square miles, they're always doing plane surveying. So that's in terms of buildings and bridges. Most things are going to be within that. And then there is geodetic surveying, which is another category of surveying, which does use calculations and GPS and a whole bunch of other factors that are not tangibly measuring the curve. And that's usually what's used beyond 100 square miles, for like, city borders and things like this when they're, property lines and so on, and state and city lines when they're using geodetic surveying. But I mean,
it's
within the plane surveying, the tools and equipment should be able to measure the curve, but they don't, and they treat it all as planar.
because the construction equipment can't build something to the millimeter, so it doesn't make any sense to do it that way. If you
What
can't
about the
build,
pyramids? What about the
wait, hold on a
Tower of
second. Well,
Babel, man?
Anthony, stop,
Sorry.
interrupting.
All right.
It-
All right.
and it-
Sorry.
no, it's okay. It's okay. Let me just get my thought, and then you can go ahead. Our, our construction standards cannot build to 0.008 inches for every 100 yards. We can't build to that level of tolerance. Well, we can, but it's not cost effective to. So why would we?
Yes, you
We don't
can.
need perfectly flat floors.
You can make pools. People make everything. You can sculpt unicorns out of ice, dude. Stop being crazy.
So when your basement, if you have a basement or a building floods, you don't see little pools of water when it goes out. You think it's perfectly flat. If it's perfectly flat, then it should coat it all evenly, but you end up with pools in low spots
The
because you
bottom,
can't make it flat.
the bottom and center of the water is going to be the thing that's in the focused in the deepest part, or wherever the
Right.
deepest part of the hole
But
is of the stuff that it's sitting on. The top surface of the water is still going to be horizontal. So I
yeah,
don't know what you're talking about pulling.
but to your point, that's exactly my point. You can't build it perfectly flat because you got these little low areas.
You just
It's
said
not
we
flat.
could. You just said we could. It's just not cost effective.
Yeah, right.
So which is
Correct.
it? So we can.
We can, but it's not cost effective. Why would you need
Okay,
to?
so but we can though, right?
Sure.
Okay, so it can be measured.
Yes.
Okay, so then you should be able to measure Earth curve, and you can't.
Yes, I can. RZAs show it
But do you know how to
perfectly.
do it?
Oh,
'Cause
you
I
can't.
don't want to speak for Raqia, but he has often stated how he has all of the tools and he's ready for anyone to
Okay.
give him a method.
Okay.
So he has all the tools. So can you tell him or anyone how to do it so we could replicate it?
Yeah, yeah. First, Raqia, what is the tolerance of the tools that you're using?
Well, I'm not going to go any further until you tell me.
That's
How
exactly
do you know
right.
this? Like, what
It,
tools have you measured it with?
you can. I haven't done it, but you can do it with reciprocal zenith angles,
And what tools would you use to do that?
2 theodolites.
Okay, but you don't use two theodolites in any surveying method. You've just watched a video on YouTube
What?
and you've been
What?
taken from it.
You don't know the tolerance of your tools, and you're talking to me like I don't
You
know
act
what I'm
like
talking.
you know the definition of tolerance that I'm using, and you're using
I
a different
do.
definition of it,
I do.
obviously, and you don't point two theodolites towards each other in any surveying method that I've ever been taught. In any surveying class, we don't use it
We're
in
not
construction.
surveying. We're
And
not
if you're
surveying.
creating a horizontal plane over a surface like a static water, which is what you would need to do to measure water. To create a horizontal plane like you're talking about slabs and stuff, you wouldn't use two theodolites pointed towards each other. You would extend
We're
a
not
straight line
talking about
segment. And if
construction.
you had water pooling in a horizontal plane, it means that that's where the water is showing that you're inaccurate, but all the other places that aren't pooling water would show that it's a horizontal plane. So which is it? Can we do it or
Well,
can't
they're
we?
the high spots. Don't you
Yeah, I
know
know where
this?
the hot spot. Yeah, the hot
Okay,
spots where
perfect.
would be where
So it's not a
where
perfectly
it
level.
drives. Yeah,
So
hang
it's not
on,
perfectly
buddy.
flat.
Hey, buddy. Hey, Wesley. You complain about being cut off, so let me finish. The high spots would be where the water would dry off first. The
Yep.
low spots would be where the water dries last. And
Yep.
all the spots in between would be perfectly horizontal. You can prove this
Nope.
with water.
So you can't make a perfectly flat foundation or
Well,
floor.
I don't think it's actually possible. It doesn't mean you can't make a horizontal line and with
Perfect.
some
Okay,
plus
great.
and minus imperfections. If you let
So
me finish and not clip me again, Wesley, the conversation will go really smoothly and make you look less idiotic when you complain about being interrupted. And then the both times that I've opened my mic, you've interrupted me. So you can make a horizontal plane. You're going to have plus and minus error margins,
yep.
which means that's where the water would show them, like if you make a horizontal plane of a pool coping and you fill it up with water, where the water flows out first is your lowest part, and where the water would flow over the coping last would be your highest part. It doesn't mean the coping's not a horizontal plane. It just means it has imperfections.
Yep. That's entirely my point. Thanks for restating my point. And then when I asked you in the chat, what is the tolerance of your equipment, and you simply respond with millimeter, that shows you don't understand what tolerance is.
I was talking about millimeter accuracy of making a horizontal line. So our
Millimeter over,
tool,
again, that shows you don't know what tolerance is. If you just respond with the word millimeter, that
what's
shows
your
you,
what's your definition of tolerance? Go ahead, because I'm
no,
not
not
talking
mine.
about. I said millimeter accuracy. So what's your definition of tolerance?
That's not tolerance.
Okay, what's your definition that
Not
you're
mine.
using right now as tolerance?
I don't have my own personal definition.
Thank you. Then how do you know what I'm saying? I mean, I don't get what you're
Because
basing it on.
there's a scientific definition for it.
Yeah, okay. What is it? Go ahead,
Okay.
post it
Sure.
or
You would
say
need
it.
for measuring distances, it would be the plus or minus a distance over a certain distance.
We're
So
not measuring distances.
what?
We're not measuring distances. We're talking about tolerance above and below the horizontal plane.
How would you measure that?
You create a horizontal plane and you measure the surface that you're trying to either the root, above the horizontal plane from a benchmark or below the
Okay.
horizontal plane from a benchmark, the surface.
My question is, how do you make that horizontal line?
Create a horizontal segment and then you extend that segment. That's what the tools are designed to do.
How do you do that?
Yeah, if you use the tools properly as they're engineered and manufactured, that is what they do, is make
Okay.
the horizontal line from point to point. They're called benchmarks.
What would you use to make a long horizontal line?
You can use a string, you can use a theodolite, a laser, auto level.
Okay, perfect. I agree with you on your auto level and your laser. What is the tolerance of your laser or your auto level over a certain distance?
Depends on the model that you use.
Right. So what is it at? What is it average to?
What do you mean? What is it? It depends on what model you use, but
Okay,
some of the theodolites are
an average.
millimeter accurate. Some of
Give
the,
me
the tolerance in accuracy are millimeter over certain distances with these really precise, highly engineered tools that are manufactured to make horizontal lines.
All right, so Raqia, over like 100 meters, what kind of accuracy? Within 1 millimeter plus and minus, or 2, or within 100
least-
meters?
Yeah.
What is it?
About 1?
Well,
1
you
millimeter?
have to. What they're giving you is what the tool's capable of. Now, what a person and like these are perfect scenarios, right? As manufactured. each one coming off the manufacturer and being being as precise it can be. That's the most precise it will ever be. Now, depending on who's setting it up, who's using it, what the conditions are, those tolerances are going to differ.
Okay, so the average tolerance of auto levels is plus or minus 1.5 millimeters per 30 meters.
Yeah,
That is
okay.
less. That is much more than the curvature of the Earth.
Yeah, but you're
By a
talking about doing
lot.
100 yards. And
I know.
and what?
So
Okay,
do
so
you
how far
understand what?
can they measure? Yeah,
Do you
I
want? Do you
understand.
understand what? Do you understand what plus or minus 1.5 per
Yes,
millimeter
I do.
per
That's the
meter?
error margin above and below the crosshair. Yep. When you
Yep.
set
So
up an instrument,
if you extend that out to 300 meters or 100 meters, what kind of tolerance would you get?
well, you're now fighting that it can't be measured. So earlier you said it can be measured. Earth curve can or can't be measured with these tools. Because you're fighting
Yes,
now that it can't be.
with a theodolite, but not with your auto levelers.
Oh, okay, well, so with a theodolite, all you got to do is do what? Go out and do what over static water?
You point the theodolites at each other, and then you measure the.
I'm sorry, bro, but man, you come on, bro.
Yeah, see,
So
he cuts in. He can't do it, so he's a hypocrite. Okay, that's fine.
no, I'm just going to simply ask you, in what surveying book did you get that from? Like, where
Not in
can
a
I learn
survey.
how to do it?
That's you want to measure the curvature of the Earth, not build a building, right?
I
Right.
want when someone's telling me you get two theodolites to point them at each other because that's the way surveyors
Nope.
measure
Now
Earth
you're
curve.
wrong. Now you're wrong.
Well, you
If
just told me that's the way they do it.
If you want to measure the Earth curve, you can
Yeah.
put two theodolites, point them at each other, and measure the angle over 180 degrees off of the plumb line.
I understand that completely. Now, what surveying book, what surveyor can I talk to, or what surveying book did he get it from?
We're
So I
not
can
we're not
find how to
doing
do
we're
it.
not we're not doing surveying. We're doing an experiment.
We're measuring Earth. That's exactly what surveying is.
Okay, but that's not they don't do this as a normal practice. I don't
I
understand
know
why
they
you're
don't. That's why I'm telling the
Okay,
audience
perfect.
this is ridiculous.
Perfect, because we don't need to measure the curvature of the Earth anymore. We already know what it is.
So let me just get this straight. No surveyor is ever going to put two theodolites and point them at each other to measure the curvature of the Earth.
Yeah, why would they do that?
Exactly. So which way
Why?
would they do it?
Answer the question. Answer the question, Raqia. Why would
Why
they
would
do
I
that?
answer illogical question that no surveyor has ever done? When we're talking about
Right,
measuring,
exactly.
hang
Exactly.
on, buddy. I'm not
100%.
going to let you. I let you clip me a couple times here and there because I thought we were just having a conversation, but now, I'm not going to let you clip
It's
me
a
during this point.
conversation. Let's keep it going. It's a conversation.
Right. So when we want to measure something and we want to use the best personnel, which would be surveyors, and the best equipment, which I agree would be, let's say, theodolites, right? The most accurate tool for creating horizontal would be a theodolite. We want to use the tools and methods most accurate, and the people that can use those tools the most accurately and create less error over distance or however many times they measure it would be surveyors. Now, what surveyor and what surveyor book? Because a surveyor would learn this from a book on how to do it, right? If it's not in the book of surveying and surveyors don't do it, then why would we use it?
Because we're not doing typical surveying.
Okay, we're not using the best typical way that surveyors would do it, so we're doing a substandard way. So who did it?
Surveyors do
I
not
ask a
measure Earth
question.
curve. Why are
I'm
you
good with that. Now, who did it? Is he better or worse than a regular
No,
surveyor?
there have been surveyors that do it, but they don't do it regularly because they don't need to.
Oh, really?
Yeah, GPS does it just fine now. Total
But no,
stations
let's
are
get back. You said the
amazing.
most accurate way would
Not a
be
quick question.
theodolites, correct?
No, I didn't. I never said that.
Okay, but that is a way you could do it. Pointing two theodolites at
Yes.
each other would be the best
Yep.
way you know of to do
I
it.
never said best. Stop saying best.
Well, that
Okay,
was
so
what
what?
you came. That's what you came up with. Go ahead, Raqia.
Yeah.
Well, when we were talking about one way that you could do it, but now they have total stations, which are much more accurate.
Do you point two of them at each other?
Nope, that they actually have GPS data with elevation from sea level, which is a curved surface.
I think you're just a
Got a
wannabe,
quick question.
like YouTuber. You watch YouTubes
Look
and
at he
you've
can't
seen
hang
a.
logically, so he insults.
Yeah,
That's
you
a
clip me
typical
again,
flirt.
bro. I'm just saying what you've done. You don't know. You're telling me I don't know.
Yeah, you
And you're
don't.
right.
You
I'm
didn't know
not.
what tolerance was. You didn't know what
I don't know
tolerance
what you
was, so
mean
you're
by
right.
that. I said millimeter accuracy over distance would be a
No,
tolerance of
you
the machine
didn't.
plus
No,
or
you
minus.
didn't. Look,
It's an
look in
error
the chat.
margin.
Look in the chat at 16 after. I said, "What is the tolerance of your measuring things?" And you said millimeter. You never said anything about over distance. So
What's your
don't
distance? What is the
exactly,
distance? No,
exactly.
I'm saying earlier you said there was like what was the millimeter difference?
100. He gave 100 yards.
No,
100 yards?
for tolerance or Earth curve.
Yeah, what was the amount you
Which
said?
one
It
were you
was like a
asking about?
certain.
Yeah,
You said
I
something
mean,
like that many millimeters.
yeah.
Your tolerance would be too high to even ever find curvature.
So
1.5 millimeters plus or
for
minus
30.
for 30 yards with an auto level is one of the things he
Yeah.
said.
Yeah, that's the
Right.
average tolerance of an auto level. Because the question was, how do you draw a straight line? Because he was right. You measure the deviation from horizontal, but first you got to establish the horizontal line. And an auto level is one way to do it, but the auto level is only accurate up to one or plus or minus 1.5 millimeters over 30 meters.
Well, how about this? Let me ask this, just maybe if this could kind of like distill the conversation a little bit. So, let's say I have I have a 1 mile swimming pool in my backyard. Okay, it's 1 mile long. It's a swimming pool that's 1 mile long. And I want to call up a surveyor and the best surveyors in the world. I've got all the money to spend so I can pay for the best guy. I want to call someone out and I want them to measure the 8-inch drop in my mile swimming pool of the water. Now, the one way you said pointing two theodolites at each other, reciprocal zenith, well, we just went through how that's not a surveying technique. That's not really going to help us here. So we throw that out. Now we're on to creating some kind of a plane of reference, a horizontal plane, and then being able to measure the 8 inches. So what surveyor and with what equipment do you think exists that with my 1 mile long swimming pool that I can call them up and I want to get a measurement of the 8-inch drop?
Total stations.
Okay, you
But
said total
here's
station.
here's yeah.
What is your
Here's the
what's your
problem.
technique? What's your
We're
technique?
gonna we're going to be talking in circles if we go to total stations because total stations give you your elevation and total stations assume that the Earth is a sphere. So we're just gonna be we could go down this path, but you're gonna go back to well they assume it's a sphere, and so you don't want I'm assuming
Total
you don't.
stations do not assume anything. They're not sentient. They are programmed. They use certain
Yes.
programs that you have to buy
Yes.
that the input of data is a sphere or curve. But
Yes. So
yeah,
they assume that it's a sphere. That's what the elevation they're giving you off
So
of a
I
yes,
All
just
right,
curve.
but I'm
calculate
asking.
it in. They take planar measurements and calculate it in with the program. Yeah, I agree.
yeah, I just took the
Okay.
method you're using, and you have a 1 to 2 millimeter error margin or tolerance, right? Like that's your
Over,
deviation, right?
over.
Over a kilometer.
Nope. Nope.
Yeah, per kilometer.
Nope.
Okay, well, you're gonna have to show me somewhere where it
Wait,
says that.
I'm sorry. I'm
'Cause
sorry.
I'm not finding
Are you talking about the
that
curvature of
method
the
with the
Earth?
theodolite to theodolite. That method, that technique, I just looked it up, and your error margin is 1 to 2 millimeters per kilometer. And then I just took the math out and ran the math out.
Okay.
Per kilometer, what's my drop? And it's like 0.67 millimeters. So you're outside your level of tolerance to detect curvature that way too. So you can never, apparently, with this method, you're never going to be able to see drop
Yeah,
over
if you I
distance.
mean, we could look it up and I'll look it up for next time, but there are reciprocal zenith angle papers. So I don't know if they had more less tolerant, but let me check.
Well, the one
Isn't the flip side?
Raqia just posted of an auto level is 1.5 millimeters per kilometer. So that is plenty. I mean, if it's supposed to be 12 millimeters at 400 meters of drop,
Yeah.
then 1.5 millimeters at a kilometer is way more than enough to measure alleged earth curve, water curve.
Yeah, I've never heard of an instrument like that, so I want to take a look at it. I'm trying to get to it.
Isn't the flip side of that a tolerance thing where the instrument isn't whatever it was? I don't remember the specific details. The flip side of it is you could make a measurement in that short of a distance, assume it's planar, but wouldn't be catching the curvature in a sense.
So this is not saying that the accuracy is. If you want to put in an actual machine that's like that, I'd really like to see that. But it's not saying that it has that tolerance. It's saying it's like that. So I
What
don't.
paper you reading?
No, I'm reading what Raqia put in chat. It says an auto level's tolerance or accuracy is the maximum permissible error in its leveling, typically expressed as millimeters per kilometer. So, like, and then it says like. So if you have one that actually has 1.5 millimeter per kilometer, I'd really like to see that one because if you type in
So
what the
when you
average,
asked what tolerance was, and I said accuracy, and then what you're reading now says tolerance is accuracy.
I
So
never said it
that's
wasn't
why I
accuracy.
asked. Yeah, I asked you what your definition of tolerance was, because in surveying terms, I thought tolerance and accuracy was the same. That's why I said millimeter accuracy, and you said I don't know what I'm talking about.
Right.
So I asked you what your definition of tolerance was, and you avoided it like the plague.
No, you still don't understand what it is because it's millimeter
It's
per
accuracy.
kilometer.
It's
Yes.
accuracy over distance, measuring whatever you're measuring.
So then why
Okay?
would you put in the chat 1 millimeter?
Because if it's one, I didn't say 1 millimeter. I
Yes,
said no, I did not. I said it's
said millimeter.
millimeter accurate. So you're going to have millimeter
No, that's
above the
not
crosshair or
tolerance.
below the crosshair. Maybe you misread, or I might have mistyped, but I've told you several times.
Sure. I asked you in
Sure
chat
what?
what the accuracy and the tolerance was, and you said millimeter.
All right,
It's
forget the chat. We're here now. Forget the chat.
Yeah, it's millimeter accuracy, which is exactly what you're
No.
reading there.
It's over. You have to give it a certain distance it's accurate over. It's like a cone, right? At the very beginning, it's very small, and then it gets wider as you go further out. So you have to give it per distance, but whatever. It doesn't really matter here. If you can find one that's 1
So the
millimeter.
further you measure, the less accurate equipment is going to be.
Yep.
I agree with that. So
Okay,
when I
that's
measure,
why the distance
when
part
I measure 400 meters to millimeter accuracy, and then you take the same tool and measure over a mile, which one's going to be more accurate?
the shorter distance.
Thank you very much.